Question 10 says a company wishes to introduce an identification number for each employee. Each number consists of 4 digits, the first digit of which is never 0. How many different numbers are there if the digits may be repeated? So the first digits I could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 digits there altogether. If the first one can't be 0, that means I can only start with a 9. So it'll be 1, 2, 3, 4, 5, 6, 7, 8 or 9. I have 9 numbers to choose from. Then I have 10 by 10 by 10 because it says repetition can be repeated, so digits may be repeated, so my answer there for that one is 9,000. Question 11, it says a church has 7 different bells in its bells towers. Before each church service 5 different bells are rung in sequence. How many possible sequences are there? So I have 5 different ones that are rung, so I drew out 5 boxes, 1, 2, 3, 4, 5. They have 7 different bells, so it's 7 by 6 by 5 by 4 by 3, which is 2,520. Question 6 said, in how many ways can the letters of the word modal be arranged? So here I drew out my box, so M-O-D-A-L, so there's 5 boxes, and I'll go 5 by 4 by 3 by 2 by 1, so there's 120 different ways. Part 2 then says, how many of these arrangements begin with L? So then I have drew out my 5 boxes again, 1, 2, 3, 4, 5. So begin with L, that means in my first box I only have one choice of a letter to put in there, so put a 1. Then I'm left over with 4 letters, so I go 4 by 3 by 2 by 1, and I'm left with the answer 24. Then part 3 says, how many do not begin with L? So I know there was 24, 120 numbers altogether. There was 24 that begin with L, so I go 120, take away 24, and I'm left with 96. Part IV says, how many end with M? So end with M, I have one choice to choose from. This box here has to be an M, and then I'm left over with 4 boxes, so I go 4 by 3 by 2 by 1, and I have the answer 24. Question 13 then, I have 7 horses A, B, C, D, E, F and G take part in a race. Assume no dead heats and all horses finish. In how many different orders can they finish the race? So what I've done is I've done out my 7 boxes because there's 7 horses, and I go 7 by 6 by 5 by 4 by 3 by 2 by 1. So this one from first, second, third, fourth, fifth, so on, all the way down to 7. And that answer there is 5,040. Then it says if A wins, how many orders are possible? So A is after winning here, so I only have one choice of a winner. Then I'm left over with, because I still have 7 boxes, there's 7 horses altogether, I have 6 horses then that can be competing in the rest of the order, so it's 6 by 5 by 4 by 3 by 2 by 1, and I get 720. Part 3 says if A wins and B comes last, how many different orders are possible? So A wins and B comes last, so that means here I'll have A is going to go into this box, the front box, and one option for B in the last box as well. So that's 2 of my horses gone out of the race, and that means I'm left with 5 horses, so it's going to be 5 by 4 by 3 by 2 by 1, which will give me 120. Part IV says, in how many ways can the first 4 horses come in? So I drew out 4 boxes, 1, 2, 3, 4, and I have 7 horses to choose from, so it's 7 by 6 by 5 by 4, which will give me 840. Question 14 says, Karen has to study 7 subjects for her Christmas Irish. So of these some are of different in which she can study her 4 subjects. So the first one is a 4 by 3, 4, and she has 7 subjects, so it's going to be 7 by 6 by 5 by 4, and there's 840 different ways that she can study. Then it says part 2, if she must start with maths. So I draw out my 4 boxes, 1, 2, 3, 4. So if she must start with maths, that means that there's only one possible outcome in here. This subject here has to be maths. And then I'm left with 6 other subjects left over, so it's 6 by 5 by 4, and my answer is 120. Part 3 says if she must not start with maths. Okay, so she can't start with maths, so that means I have 6 subjects to choose from. And then I'm still left with 6 subjects left over by 5 by 4, and I could also say that that's going to be 840 take away 120, which is 720. So this answer here will give me 720. Part IV of this says if she must start with a language. Okay, so I still have my 4 boxes, 1, 2, 3, 4. There was 3 languages in this case, so she has the choice of 3 languages to start off with, so that's why I have a 3 here. So that's only one choice, so let's say she chooses English, she still has 6 subjects left over that she can choose from, so 6 by 5 by 4, and I get 360. Part V says if she must not start with a language. So if 3 of them are languages, that means the 4 of the subjects there are not languages. So my first box here, I'll have 4, so that's 1 subject gone, and I still have 6 subjects left over, so 6 by 5 by 4. Question 15, it says how many 3-digit numbers can be made using any of the digits 2, 3, 4 and 5 if repetitions are not allowed. Okay, so then for part I have 3 numbers, 1, 2, 3, so I'm using 3 boxes, and then I have 4 numbers to choose from by 3 by 2, so there's 24 for this one. Part 2, if repetitions are allowed. So here I still have my 3 boxes because I'm making 3-digit numbers, and I have 4 numbers to choose from for the first box, 4 numbers to choose from for the second box, and 4 numbers to choose for the third box. So that answer there is 64. Part 3 then of this question, it says if repetitions are not allowed, how many of these numbers are odd and how many of them are even. Okay, if they're going to be odd, they have to end in an odd number, and 2 of these numbers are odd, so this here is going to be 2. Then I'm going to be left, so this is one of the numbers gone, so I have 3 by 2 here, which will give me 12. Then if we're going to deal with even, okay, so we'll have even, well we know the total number here is 24, so if 12 of them are even, that means 12 of them are odd, but it's the same principle which we apply here. So question 16, it says a password for a computer system consists of 3 different digits followed by 2 different capital letters. How many different passwords are possible? So we have 3 different digits and then 2 letters. So I have here, these are my 3 digits, 2 letters. So if I have 3 different letters or numbers, I could have 10 numbers that I can choose from possible. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which will give me 10. So for this one, I'll have 10 by 9 by 8. So that's my digits with no restrictions. And then it says my 2 letters, so there's 26 letters in the alphabet, so 26 by 268. The next one then, it says Ian forgets his password but knows that the first number is 5 and the last letter is A. So I still have my 5 boxes like so. So I'm told he forgets his password but he knows the first number is 5. So that means in this box here there has to be a 1 because that one there is going to be 5. And he also knows that the last letter is A, so in my letter I'll have A, that has to be 1. Then I'm left over by 8, it's going to one letter A, and I get 1800. Question 17, it says how many 3-digit numbers can be made from the digits 5, 7, 8 and 9, and no digit can be repeated. So I'm 3 digits, so I have 3 boxes, and I have 4 numbers there, so it's going to be 4 by 3 by 2, which will give me 24. Part 2, it says if the number is even. So if the number is going to be even, it has to end on an even number. So in this case here, I only have 1 even number. So my 1 is going to go here. So this one will have to be 8. Then I'm left over with 3 other numbers. So it's going to be 3 by 2, and that will give me 6. Then it says if the number is odd. Well, I know there's 24 here altogether. And then if 6 of them are even, I go 24, take away 6 will give me 18. But I also could use it using my boxes here. So if the number is odd, that means it has to end in an odd number. So I have 3 choices that can go in my last box. That's 1 number gone, but there's 3 numbers left over, so it will be 3 by 2, which will give me 18. The next one then, it says if the number is over 700. If the number is over 700, it's going to have to be in my first box 7, 8 or 9. So I have 3 numbers to choose from here, so one of them is gone. So let's say I take 7, that means I have 3 numbers left over, so it will be by 3 by 2, which will give me 18. Question 18 then, it says in how many ways can the letters of the word triangle be arranged if there are no restrictions? So I drew out a box for each letter in triangle, and there's 8 letters in triangle, so I said 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1, or 8 factorial, and I get 40,320. Part 2, it says if the arrangement must begin with n, so I draw out my 8 boxes. must begin with N. That means in here I only have one choice. It has to be N. And then I'm left over with 7 other boxes, so it'll be 7 by 6 by 5 by 4 by 3 by 2 by 1, and I'll get 5040. Part 3, it says if they must begin with a vowel. So I look here, in triangle I have 3 vowels, so they must begin with a vowel. So in the first box I put 3, that's one letter gone, so I'm still left then with my 7 by 6 by 5 by 4 by 3 by 2 by 1, and which will give me 15,120. Part IV, it says if the 3 vowels must come at the start. So that means my 3 vowels here must come at the start, and then I'm going to have 3 by 2 by 1, and then I'm left over with 5 by 4 by 3 by 2 by 1, which will give me 720. Next question I have is question 19. So it says 3 girls, Aoife, Betty and Carol, and 2 boys, Darren and Owen, are to line up for a photograph. How many different ways are there of arranging them in a straight line if they may line up in any order? So there's 5 of them all together, so I drew out 5 boxes. So it's 5 by 4 by 3 by 2 by 1, which will give me 120. Then I have if they must be in girl, boy, girl, boy, girl. So here I drew out 5 boxes again. So I have 3 girls to choose from at the start. Multiplied by boy, I only have 2 boys, so I put in 2 here. Multiply, now I have a girl, so I'm after taking 1 already, so that means I have 2 left over to choose from. By a boy, I have only 1 left over to choose from. By a girl, I only have 1 left over to choose from, so my answer is going to be 12. Question 20, it says, in how many different ways can the letters of the word piglet be arranged if there are no restrictions? So I drew out my boxes, and there's 6 letters in piglet, so I did 6 by 5 by 4 by 3 by 2 by 1, and I get 720. Then it says part 2, if the arrangements must begin with a vowel. So in the word piglet I have 2 vowels, so if it must begin with a vowel I have to put 2 in my very first box, which is here. And then I have 5 boxes left over, 5 other letters to choose from, so it'll be by 5 by 4 by 3 by 2 by 1, which will give me 240. Part 3 says if arrangements must the vowel and end with E. So we have 2 vowels, so that's going to go here, and if it must end with a T, I must fill in this box here. Okay, so that's 2 letters gone there out of my 6, so that means I'm left at 4 by 3 by 2 by 1, and my answer is 48.